Alright guys, today we're going to learn about the fundamental counting principle. The name is harder, it sounds harder in the name than it is actual stuff. You've actually probably been doing some of it, you just didn't know it. So, the fundamental counting principle can be used to find the number of possibilities when given several groups. So, one way you can use the FCP, that's what I'm going to call it, is when you're used to find the number of possibilities when given several groups. Like, several groups would be like, you have 5 shirts, 6 pairs of pants, and 2 different pairs of shoes. How many different outfits can you make? Well, then you would just multiply the number of elements in each group, and that'll be your fundamental counting principle answer. The other way, I'm going to scroll down. The other way, well, we're going to learn permutation and combinations the rest of this week, but we're starting with the FCP. So if you can repeat objects, so if objects can be repeated, then you have to do the fundamental counting principle. So like, with a password, it says you can repeat letters and stuff like that. You would have to do the fundamental counting principle, okay, which we're going to do examples of those. All right. So up here, they're doing tree diagrams for you. So it says that you have ice cream cones come in a cup or a cone. So that's 2 possibilities in that one group. And then your next group is flavors, which is 3, chocolate, strawberry, and vanilla. So, as it says, you multiply the number of elements in each group. So, there are 2 elements here, 3 elements here. So, 2 times 3 would be 6. And if you counted these, 1, 2, 3, 4, 5, 6, it would match your answer. Okay? The next one's just showing it backwards, but I also want to show that it doesn't have to be just 2 groups. It can be more than 2 groups. So, say that you had toppings. Okay, and your topping choices were chocolate chip and sprinkles. That's your third category. So we would add a third row here, which would be sprinkles or chocolate chips. 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 Now, you would do the same thing. You've got 2 options here, 3 options here, and then 2 options here. Okay? We're not looking at how many there are of each combination right now. You're multiplying how many options you have. So you can either do a cup or a cone. You can either do chocolate, strawberry, or vanilla. And then you can either do sprinkles or chocolate chips. So then that's going to be 12 different outcomes. And then if you count your last column, because as you learned in Math 2, that's how you find your total, counting your last column. We would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this just helps you from having to do the tree diagram to find your number of outcomes. Okay? All right, so it just tells you what we went over. Now you can do it with license plates also, but what I want to talk about here is how many options you have. So when you're talking about letters, there are 26 letters in the alphabet, so you would have 26 possibilities for a position that needed letters. So these first 3 blanks need letters, so that's why I see 26, 26, and 26. Okay? Now, when you're doing numbers, you have to think about it. You're doing one slot, so only a single digit number can go in there, and your single digit numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 gets to double digits, so you have to stop. But when you count it, because you're including 0, there are 10 possibilities for single digit numbers. That's why it's 10 times 10 times 10, which is going to give you this as your answer when you multiply them together. Okay? So let's do some examples. We're going to start off with the category of groups, and then we're going to do ones like this right here. Okay? My child. So, how do you know it's a fundamental counting principle? Again, groups cannot repeat. Okay? You can do can repeating too. You can do both can and cannot repeating with fundamental counting principle. Okay? So, it says, suppose most of your clothes are dirty and you're left with 2 pairs of pants and 3 shirts. See how it's talking about 2 different groups? That's how you know it's a fundamental counting principle. So you have 2 elements of pants and 3 elements of shirt. So you would have 6 different ways you could dress that day. Alright, number 2, you go to a restaurant, get some breakfast. The menu says pancakes, waffles, or home fries. So in this category, there are 3 elements. Okay. The next category talks about for your drink. Now, drinks not included. Your options are coffee, juice, hot chocolate, and tea. So that's 1, 2, 3, 4. And how many choices of food and drink do you have? Well, 3 times 4 would be 12. Okay. This one does images. So you have 2 body styles. So there's 2. 5 colors times 5. 3 models. So that's going to be 30 different cards you can make. Okay. See how it's giving you different groups? It's not talking about one thing. It's talking about multiple different things. So now this one, this is where it comes into the can be repeated. So you have to, anytime you see can be repeated, you have to use a fundamental counting principle. So you're assigned a computer-generated 4-digit password. So 4 digits, 1, 2, 3, 4. I like to do the blanks. It helps me out, especially when you're doing passwords and passcodes. I like to do the blanks amount of numbers or whatever it can be. So access your new voicemail account. So when I access my voicemail account, okay, it wants to be digits. So remember, your single digits, there are 10 single digits you can choose from when you're making a password. Okay, now it can repeat, so that means you can use 10 here. I can use 0 through 9 here. I can use 0 through 9 here, and same. Multiply them together. Okay, you get 40,000. Okay. I don't know why I said 40,000. That's not right. I was doing, there was 4. It's 10,000. I put the 4 because there was 4 blanks. All right. So 10,000 would be your answer. All right. So now I want to go to one more problem of what's the difference between you can repeat and you cannot repeat. So here for problem 1 and 2, it wants me for A, digits that can repeat. So we're going to do digits that can repeat first. So here, so for A, it's 3 digits followed by 4 letters. So 3 digits, 4 letters. Okay? Now, you can repeat. So remember, recap, letters. We have 26 letters. And digits are numbers. This page uses digits, so we'll use digit. There are 10. So I can repeat. So I can use 0 through 9, 0 through 9, 0 through 9. Letters, I can repeat them. A through Z, A through Z, A through Z, A through Z. I'm definitely going to use a calculator to do this. I get my answer to be this. Okay? Now, the next part B, says that they cannot be repeated. So you have to use fundamental counting principle when you can be repeated, but you don't have to when it cannot be repeated. You can do a permutation or a combination. But since we haven't learned that yet, fundamental counting principle, okay? So again, I have 7 blanks. Now, when you cannot repeat, you use one and lose one. So I use a number here, I lose 1 to 9, and then I lose another 1 to 8. Okay? Now, the next one are letters. I start out with 26 letters, but I use one, I lose one. Lose another, lose another. I'm going to multiply these numbers together. Okay. And I get this. And now if you notice, it's actually small. It's kind of almost cut in half. Because you're restricting yourself by not repeating numbers. So that's why it's smaller, okay? So can repeat, cannot repeat. All right, it just shows you that if you cannot repeat, you use one, you lose it. All right, so that is it for today's lesson. If you have any questions, feel free to email me. You're going to have a probably 4-question assignment I'm going to find. I'll put it on Canvas. So just go to Canvas to find what to do next. All right, bye guys.